Okay, now look at the first part of the diagram. I'll minimize it so that you can focus on the first diagram. Now look at this one, submerged bodies. So everything is surrounding liquid is there. Huh? Everything surrounding liquid is present. Liquid is present. So what do you mean by stable equilibrium? Or first we'll go for neutral equilibrium. What do you mean by neutral equilibrium? Where the buoyant force and the weight will act through the same point. Where the what do you mean by same point? The force of action, like the weight. Where do weight will act? To the center of gravity. Or center of mass, better you say. What is the buoyant force? So what about the buoyant force? So B is called as center of buoyancy. So here we define like this. This is called as and C is called as center of gravity. And now you see that both the things we define. What do you mean by center of gravity? We know that one. Where the effective weight of a body will act, or for your convenience, you can also write center of mass. I think that this will really help you a lot. No, what about center of buoyancy? The body will have volume immersed. No, volume immersed. The center of volume immersed of a body will become center of buoyancy. The center of volume immersed will become center of buoyancy. Okay, look at this one now. Definitely you can select a center of gravity. Center of gravity is what I'm just taking to be here now. Of the body. Center of buoyancy. The center of buoyancy of this body will come here. Okay, now this is in equilibrium. This is in equilibrium. Slightly, I will tilt it. I'll tilt it. Then if I tilt it, then you can see that so no, what will happen to buoyant force? The buoyant force will set up a torque about the gravity. The center of this buoyant force will set up a torque about this one, and it will set up an anti-torque. So it was given angular displacement theta like this. How the torque is acting. Who will set up torque? The buoyant force. The buoyant force will set up an anti-torque in this one. So because of that it will come to the stable equilibrium. Able to analyze this? Sir, how come now you have to ask one good question. Sir, how come center of gravity should be here? Center of gravity should be somewhere here. Here I made it heavier. Some metal, something I'll add it, I'll make this part heavier. So when this becomes heavier, so definitely center of gravity, instead of to be here, it will shift down. Okay, let's not bother. Let's assume that center of gravity lies somewhere here. Center of buoyancy lies above that. When you give slight tilt, the buoyant force will set up a torque and anti-torque will be set up here. So shall we call this a unstable equilibrium? What do you mean by stable equilibrium? When you disturb a body about its equilibrium, if a restoring torque or restoring force will act, it's called a stable equilibrium. A restoring torque is set up. So this is about stable. What about unstable? If the center of gravity lies above the center of buoyancy. Okay, in this case, now you see that one. If I give slight tilt, I'll give slight tilt. Then how the torque will act in same direction. Who will set up? Let's assume that above the gravity, the buoyant force will set up torque. So how the torque will be? Clockwise. Able to analyze? The clock will be. Sir, how to calculate the center of buoyancy? It's not a part of syllabus, just only theoretical discussion. Even in our most of the books, there is no discussion on this one. How to calculate center of buoyancy? Let's not bother. The center of volume immerse will lie somewhere here. Let's assume that one. Now the buoyant force will set up a torque about gravity, and it will act like this. Or you go back to the rigid body mechanics. From that, if a rigid body is set free to rotate, it will rotate about center of mass. There's the idea, no? If a rigid body is set free to rotate, rotate about center of mass. So therefore, the torque due to buoyant force will act about center of mass. It will set up a restoring torque. The same thing here. What about here? Now, neutral equilibrium. You give twist in whichever position the buoyant force and weight will act through that point only. So therefore, in you give angular displacement, the body will be in that position only. It will not change its orientation. That's called like a neutral equilibrium. So what do you mean by stable equilibrium? If a rigid body is submerged in a liquid, when you give some angular displacement, if the torque by the buoyant force about center of mass acts at opposite angular displacement, it's a stable equilibrium. If a rigid body is submerged in a liquid, totally submerged in liquid, then if you give angular displacement, if the torque due to buoyant force acts in the direction of angular displacement, then it will be unstable equilibrium. What do you mean by neutral equilibrium? You give angular displacement in that position only, the body will rotate. Suppose say like a neutral equilibrium, the idea of that I'll put it. Suppose that there's a, we'll take some arrow as a reference for us. There's a neutral equilibrium. You tilt this body, it will be there in that position only. Finish. In whichever position you bring it, it will retain that position. There's a meaning of neutral equilibrium. Get in this one. So I brought some other shaped rod again. So here is given a clear like a diagrams also there. Theta like this, no? And what about theta? Okay, sorry. Theta is like this. Stable equilibrium is explaining. Only stable equilibrium. So for stable equilibrium, what is the necessity condition? The center of buoyancy should lie above the center of gravity. Am I right? So shall I put simplest conclusion? Center of above center of gravity. Here, center of buoyancy lies below the center of gravity. Okay, now you know boat. I think there's a boat. It has to, or boat or ship, what all we manufacture. No? So it should be how we design. We do design it like this, no? So what will happen? What is a boat? Usually it is made up of wood, no? Then what should be the boat? Should be stable or unstable equilibrium? Should be stable equilibrium. For that purpose, what will happen? We will just add